Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0172, indicates an issue with the fuel system, specifically that it is operating too rich. This means that there is an excess of fuel in the air-fuel mixture that the engine receives, which can cause numerous performance issues. In a modern vehicle like the 2023 Honda CR-V, several components work together to ensure the correct mixture of air and fuel enters the engine. When the Powertrain Control Module, PCM, detects a long-term fuel trim, LTFT value that's lower than specified, it signals that an abnormal condition is present and sets the DTC P0172. This situation could be due to various system failures or incorrect vehicle configurations. Misdiagnosing this code could lead to unnecessary replacements and expenses. Therefore, accurate troubleshooting is crucial. DTC P0172 pertains to the fuel system being too rich, where the PCM makes adjustments based on the LTFT values. This error implicates several components, each playing a critical role in fuel delivery and management. Key components include the mass airflow, MAF sensor, which measures the amount of air entering the engine, the AF air-fuel sensor, which monitors the air-fuel mixture, injectors that deliver fuel into the combustion chamber, and many more. These components are strategically located across different parts of the vehicle, such as the engine compartment for sensors and below the throttle body for injectors. Correct functioning of these components is vital for maintaining a balanced and efficient fuel system. Several potential causes can lead to the setting of DTC P0172. Aftermarket fuel system or engine components can drastically change engine performance and may lead to this error if not compatible with Honda's specifications. Leaky fuel injectors are another possibility. They may allow excess fuel into the combustion chamber, upsetting the air-fuel mixture. Another common cause is a faulty MAF sensor, which could misinterpret the amount of air entering the engine, leading to incorrect fuel delivery. Any issue affecting the built-in diagnostic tools can mislead the PCM into thinking the fuel system is rich when it may not be. Thus, accurate diagnostics should always be employed. When the P0172 code is triggered, you may notice several symptoms. Engine stalling is a common occurrence, specifically during idle or low-speed conditions. This results from excess fuel, causing misfires or an unstable combustion process. Additionally, poor fuel economy can become apparent as the vehicle begins to consume more fuel than anticipated. Rough idling may also manifest, leading to an unpleasant driving experience. Monitoring these symptoms can provide crucial insights into the urgency of addressing the P0172 error code. Neglecting these signs could lead to further engine complications down the line. The first step in troubleshooting DTC P0172 requires starting the engine and allowing it to idle without any additional load, ideally in park P or neutral N. This idle condition is key as it helps establish a baseline for the fuel mixture and allows the Honda Diagnostic System, HDS, to accurately record parameters. Next, check the fuel trim value, specifically the short-term fuel trim, AFFB. If this value reads below 0.79, the failure has been successfully duplicated, indicating a rich fuel mixture that requires further diagnostics. This starting point sets the stage for subsequent steps in the troubleshooting process. For this step, begin by reviewing the onboard snapshot from the HDS, focusing on the recorded value of the short-term fuel trim, AFFB, when DTC P0172 was initially set. It's imperative to note the vehicle's conditions during this time, including engine speed and vehicle speed. Once this information is gathered, perform a test drive under similar conditions that existed when the DTC was triggered. Pay close attention to the values recorded by the HDS during this driving cycle. If the AFFB during the test drive exceeds 0.79, the failure condition has been confirmed, further necessitating a deeper investigation into the components involved in the fuel management system. The next phase involves performing a fuel pressure test. First, ensure that the engine is running and maintain an engine speed of 3,000 RPM without load until the radiator fan engages. Then allow the engine to return to idle. At this point, utilize the HDS to conduct the diagnostic fuel pressure test, which measures the pressure in the fuel system. A normal result should report back as normal. If the results deviate from this, review other related DTC codes such as P0087 or P0088, as they indicate potential issues with fuel pressure that could be contributing to the rich fuel condition indicated by DTC P0172. To address potential issues with the MAF sensor, the engine should be started and allowed to idle under controlled conditions. Key settings should include an engine coolant temperature, ECT, above 176 degrees Fahrenheit, 80 degrees Celsius, transmission in park or neutral, and all electrical loads turned off. Once these conditions are ensured, monitor the MAF sensor value using HDS while holding engine speed at 2,500 RPM for about 30 seconds. Normal conditions dictate that the MAF sensor values range between 4.1 grams per second and 5.7 grams per second. If the sensor readings fall outside this range, it indicates a malfunction of the MAF sensor or the integrated air temperature IAT sensor, necessitating further inspection or replacement. Start the engine and let it idle before pinching the positive crankcase ventilation (PCV) hose. This action allows for observing any changes on the HDS in terms of short-term fuel trim AFFB values. The goal is to ensure that the AFFB stays below the critical threshold of 0.79. If the value exceeds this threshold, it may indicate fuel contamination within the engine oil due to potential malfunction of components such as faulty fuel injectors. This requires that both the engine oil and oil filter be replaced to eliminate contaminant risks and ensure a healthier engine operation. Proceed with inspecting the EVAP, Evaporative Emission Control System canister purge valve. This involves disconnecting the connector and the vacuum hose from the purge line leading to the engine compartment. Connect a vacuum pump point/gauge rated at 0 to 30 inches of mercury to the purge valve. With the engine idling, observe the gauge reading. Normal conditions require 0 vacuum, indicating the valve is functioning correctly. If the gauge indicates a vacuum, it signifies a malfunction in the purge valve. Therefore, it must be examined or replaced. It's essential since a faulty EVAP can indeed introduce extra fuel vapor into the intake manifold, thereby contributing to a rich fuel condition. Due to the lack of direct testing methods for fuel quality, this step involves replacing existing fuel with a known good component. Drain the fuel tank thoroughly and refill it with high-quality gasoline from a reputable source. After replacing the fuel, attempt to reproduce the failure condition that triggered DTC P0172. If the error persists, it suggests that another component, unrelated to fuel quality, is at fault. However, if the DTC goes away, it indicates that the previous fuel was indeed a contributing factor to the problem and should be marked as the cause of the rich mixture. For AF Sensor 1 inspection, like many previous steps, replacing this sensor with a known good part is vital for accurate diagnostics. This step involves disconnecting the existing sensor and installing a trusted replacement to see if the error persists. Given that there may not be direct methods to verify sensor functionality, observing the system's response after replacement helps confirm whether the AF sensor was faulty. Should the complexity of the DTC P0172 clear up following the swap, it indicates the sensor was to blame, and it needs proper replacement to restore engine performance. Besides checking the fuel quality and the AF sensor, examining fuel injectors is crucial in this troubleshooting process. Similar to previous inspections, utilize a known good injector to replace any suspect units and attempt to recreate the original failure conditions. Faulty injectors may deliver uneven quantities of fuel to the engine, exacerbating the richness problem. Thus, testing known good injectors is integral. If replacing the injector resolves the DTC symptom, it proves it's worth the effort. This confirms that the original injectors were indeed defective and highlights the importance of continuous monitoring for fuel system integrity. The final troubleshooting step is to inspect the powertrain control module, PCM, which is the central brain of your vehicle's engine management system. If all previous components have tested positive or displayed normal conditions, yet DTC P0172 continues to set, the PCM may be the shadow culprit. Investigate the PCM for any signs of malfunctioning or improper programming. Ensuring the PCM is operating correctly is vital, as it utilizes inputs from various sensors to maintain optimal engine performance. Should any issues with the PCM be identified, replacement or reprogramming might become necessary. After completing the necessary repairs and replacements, the last step is to clear all DTCs from the PCM. This action ensures that any history of previous errors is removed, allowing for a fresh diagnostic state. Once the DTCs have been cleared, a thorough test drive is crucial to replicate actual driving conditions. During this test drive, continuously monitor the HDS for any returning codes or discrepancies in sensor values. Confirm that all systems are operating within normal parameters to validate the effectiveness of the performed repairs, ensuring complete resolution of the original P0172 issue. To prevent the recurrence of DTC P0172, regular preventive maintenance is key. Schedule periodic routine checks of all fuel system components, including the fuel injectors, sensors, and PCM. This helps catch any early signs of malfunction before they escalate into significant issues. Additionally, using quality fuel from reputable sources can avert fuel contamination, a known trigger for rich conditions. Furthermore, always ensure to inspect the engine oil periodically for contamination from fuel or other foreign substances. Keeping these maintenance practices will prolong your vehicle's lifespan and performance, reducing the likelihood of DTC issues. In conclusion, understanding and diagnosing DTC P0172 involves a thorough examination of the vehicle's fuel system and its components. Recognizing the potential causes and symptoms helps pinpoint issues accurately, from faulty sensors to fuel quality problems. The importance of each component, from the MAF sensor to the PCM, cannot be understated, as they work in tandem to ensure optimal performance. Timely repairs not only resolve current issues, but also prevent future complications, making ongoing maintenance an essential part of vehicle ownership. Applying the troubleshooting steps detailed ensures that owners can efficiently address and correct rich fuel system conditions when they arise. Please like and subscribe to the channel. See you next time!